Welcome dear students. In the last lecture we discussed in detail what is optical isomerism, and now let us see the difference between the enantiomers and diastereomers. Both are the types of the optical isomers, both are related to the topic of the optical isomerism. Enantiomers are mirror images of each other and non-superimposable. Enantiomers are those optical isomers which are mirror images of each other, just like your two hands. Left hand is the mirror image of the right hand, and right hand is the mirror image of the left hand. And they are non-superimposable. Again, just like your two hands, you cannot superimpose the right hand on the left hand or left hand on the right hand just like this. These are two hands, so they are not superimposable as the fingers and the thumb, they do not match. And they always exist in the form of pairs, again like your two hands which are pair of each other. Left hand is the mirror image of the right hand is the mirror image of the left hand, and hands are in the form of the pair. Enantiomers have same physical and chemical properties. They have same melting point, boiling point, density. They are basically just two identical compounds that have different direction of the rotation of the plane polarized light. The one rotates plane polarized light towards the right or clockwise, that is dextrorotatory. The other rotates plane polarized light towards the left, that is levorotatory. Both rotate the plane polarized light in different direction with equal magnitude. That's why one is shown with the positive sign and other is shown with the negative sign. And they are chemically same. Basically, they are two identical compounds, as I have all mentioned earlier. They have same reactivity towards different reagents. So their rate of reaction, that is also same. Positive and negative isomer both have same speed of their reactions. Now, what are diastereomers? Diastereomers are non-mirror images. They are not mirror images of each other. And they are non-superimposable, just like enantiomers. Enantiomer always occur in pair, but diastereomers can be more than two. There can be many compounds which may be diastereomers of each other. They have different physical properties. Their melting point, boiling point, density, that is different from each other. But keep one thing in your mind, that diastereomers chemically they are also same. But their reactivity, their rate of reactions, that may be different. Basically, enantiomers have same molecular structure, while diastereomers they do not have same molecular structure, due to which they have different physical properties and different reactivities. Now let us consider an example that will clear the concept of both enantiomers and diastereomers, that is 3-bromo-2-butanol. Now this one is a form of 3-bromo-2-butanol. This one is B, another form of the 3-bromo-2-butanol. You can see that A and B are mirror images of each other. This line in green is basically a mirror, and A and B are mirror images of each other. You can see this. So A and B, they will be enantiomers of each other, as they are mirror images and they are non-superimposable. In the same way, look at this C and D, they are also mirror images of each other. This green line again represents the mirror, and they are mirror images, non-superimposable. So C and D, they are also enantiomers of each other. So this one is a pair of the enantiomers, and here is another pair of the enantiomers of the 3-bromo-2-butanol. But what's about the diastereomers? Now compare A with C. A and C, they are not mirror images of each other. You can see OH and here H. These are not mirror images of each other, but still they are non-superimposable. So A will be and C, they will be diastereomers of each other. In the same way, A and D, again both are not mirror images of each other due to this difference of hydrogen and bromine. So A and D are diastereomers of each other. So A, C, A, D, they are diastereomers of each other. Similarly, B and C and B and D, they are also diastereomers of each other. They are not basically mirror images of each other. You can see the difference between B and C at this bromine and hydrogen. If there will be mirror between them, then they will not be mirror images of each other. And similarly, B and D, due to this H and OH, they will not be mirror images of each other. But all these forms of the 3-bromo-2-butanol, they will be optically active. They will rotate the plane polarized light either towards the right or towards the left. So enantiomers are in pairs, but diastereomers, A with C, A with D, similarly B with C, B with D, so they may be more than two. There may be many molecules that may be diastereomers of the each other. And all these, they have two stereo centers. These two carbons, they are attached to four different groups. They are sp3 hybridized carbons. They are chiral carbons. So all these, they have two stereogenic centers or two stereo centers. So that is the brief difference between the enantiomers and diastereomers. Next time we will come up with some new lecture. Till then, take care.